Hey guys, welcome back to another video. So in today's video, we're going to discuss a question that came from the physics paper in the JEE Advanced 2024 examination. So the question's right here. Let's read the question. The specific heat capacity of a substance is temperature dependent and is given by the formula C is equal to kT, where K is a constant of suitable dimensions in the SI units and T is in the absolute temperature. If the heat required to raise the temperature of 1 kilogram of the substance from -73 to 27 degrees Celsius is Nk, then what is the value of N? Okay. So the first thing I'm going to do here is write down some of the important things that they gave us in the question. So they told us that C is equal to KT. That's the first thing. And they also told us that T is in absolute temperature. So what I'm going to do right now is I'm going to convert these temperatures given to us in absolute temperature, or Kelvin. So I'm going to convert those first. So we know that, they gave us this. Using that, we can, figure out what these are. So this would be 200 Kelvin, and this would be 300 Kelvin. So basically, our temperature here is increasing from 200 to 300 Kelvin. We also know a formula when it comes to heat capacity, and that is mc delta T is equal to Q. Q here is our heat, and the heat required to raise the temperature of 1 kilogram of the substance. So here what we're going to do, I'm going to plug in some values basically. So let's see. They told us that M is equal to 1 kilogram. And they told us that T initial is 200 Kelvin. T final is 300 Kelvin. And they also told us that Q is equal to Nk, as well as C, which is equal to KT. So these are all the pieces of information they've given us in the question. Now all we have to do is find what N is. So here C, the specific heat capacity, is varying with temperature. So when C varies with temperature, we can't directly substitute some formulas and do whatever. That's not possible. What we do here, instead of this, which represents a huge change or a non-negligible change, instead of huge, we can say an actual visible change in temperature. That's what delta represents, right? So visible change. What we're going to use is something different, but essentially the same thing. We will use this. So this talks about the entire process, while this talks about just a teensy portion of that process. And when we integrate both sides, or sum up all of the changes in heat on both sides, then we'll get the complete amount, or Nk in this case. So let's do that. So this I'm going to solve. mc dt equal to dq. So dq is equal to, this is 1 kilogram. So 1 times KT times dt. So that means dq is equal to kt dt. And now what I'm going to do is I'm going to integrate both sides. From T is equal to this, or the initial temperature, to the final temperature. So this would be 300 Kelvin to 200 Kelvin. So now we know that the complete dq, or the sum of all the small portions of heat, or the small changes in heat, is given to us as nk. So what we're going to do here is, after integrating or summing up all this little changes in heat, we would get nk. So I'm just going to put that right there. And now our job is to integrate this. So since k is a constant, we can bring it outside of the integration. So this would just be t dt inside. We also know basic integration. So when we integrate this, actually, we don't need this anymore. I don't know why I wrote it again. So k times, okay, so basically the integration of x dx. This is equal to x squared over 2 plus c. Now when we're applying limits, this plus c, basically it would be, subtraction of the limit substituted in this. You probably know integration, so just do that. So yeah, what we're gonna do here is x squared over 2. Sorry, not x. It would be t squared over 2 from 300 to 200. And this is equal to nk, by the way. We can cancel these k's out. So n would just be the substitution of this. So 300 squared over 2 minus 200 squared over 2. And that's equal to 90,000 over 2 minus 40,000 over 2, which is 50,000 over 2, which is 25,000. And that's equal to n. So that's our answer for this question. So that's the question from the JEE Advanced 2024 Paper 1. We'll get to more questions from that paper in the future videos. Thank you for watching.